Hi everyone and welcome to Smart Alex Coaching. In our last video, we looked at how to use Prim's algorithm to find the minimum spanning tree. In this video, we're going to look at another method which is called the Kruskals algorithm. The main idea of Kruskals algorithm is that we're creating a minimum spanning tree by connecting together edges with the lowest weights. Unlike Prim's algorithm where you can start off from any vertex, with Kruskals algorithm, you want to start off from the edge with the minimum weight. Looking at this graph, edge BC has got the minimum weight of 1, so I'm going to highlight edge BC to indicate that this will be part of my final minimum spanning tree. You then continue finding the edge with the next lowest weight. Edges AB and EF have got the next lowest weight of 3. You can choose either one. I'm going to choose EF in this example. At this point, edges BC and EF are not connected. The aim of Kruskals algorithm is that you want to continue the process to eventually include all the vertices and make it a connected graph. So next we repeat the process again. We're going to look for the edge with the minimum weight. In this case, it happens to be edge AB, which has a weight of 3. The next minimum weight is 4, which are edges DF and CE. Doesn't matter which one you choose. I'm going to choose edge DF. And next edge is going to be edge CE with a weight of 4 as well. And at this point, I've collected all the vertices and it is a connected graph. So I now have our minimum spanning tree. The length of this spanning tree is given by the sum of the weights of the edges. So the length will be equal to 3 plus 1 plus 4 plus 3 plus 4, which is going to be equal to 15 units. Here's another example on how to apply Kruskals algorithm to find the minimum spanning tree. You first start off with the edge with the minimum weight, which happens to be edge CD in this graph. Next is edge DE with a weight of 3. We now have 3 edges with weights of 4, CE, CF, and BF. We're not going to include edge CE into our graph, since vertices C and E have already been included in the tree and it doesn't need to be connected. So I'm going to choose edge BF in this case. Next, I'm going to choose edge CF. It does not give us any new vertices. However, it does allow us to connect the 2 branches of the tree together. The next edges with the next minimum weight of 5 are edges AF and FE. Again, same argument. We don't include FE since that does not benefit our final tree, does not give us any new vertices. So I'm going to highlight edge AF instead, and that's going to allow us to include vertex A into our graph. Even though edge AB has got the next minimum weight of 6, we're not going to include that either since that does not give us any new vertices into our tree. So the next edge we're going to include is going to be edge BG. And this produces our minimum spanning tree. It includes all the vertices as well as having everything connected together. The length of this tree is given by the sum of the weights of the edges. So the length is going to be equal to 8 plus 4 plus 5 plus 4 plus 2 plus 3, which is equal to 26 units. Thanks again for watching this video, everyone. I hope that you did learn something from it. If you did like it and if you did find it useful, please help us by clicking like below and share it. We release videos every week covering topics from Year 3 to Year 12 mathematics. So don't forget to subscribe. We'll see you next time in the next video. Bye for now.